In the lab, there were unlabeled substances, and it was up to us to identify them. By performing different tests, we were able to discern each substance's properties and then their identities. We tested for properties such as solubility, conductivity, and melting point. The outcomes of these tests would provide information such as bond type and polarity. By adding small amounts of our mystery substances to water, we tested solubility. If a substance dissolved, then we knew that it was formed by ionic bonds. If it would not, then it was covalent. This was because water is polar, so the ions in the ionically bonded crystal lattices would break apart because of their attraction to the water molecules. As an extension of this concept, dissolved ionic compounds conduct electricity much better than covalent bonds because the dissolved ions are free to flow and conduct electricity. The mystery substances were also exposed to hexane and ethyl alcohol. Their reaction to these liquids, or lack thereof, would give clues to the molecular composition and the bonding of the mystery substances. The mystery substances also underwent heating over boiling water and/or a Bunsen burner. The boiling water would provide relatively low heat, which would cause covalently bonded substances to melt. The Bunsen burner would provide relatively higher heat that might melt stronger covalent bonds or weaker ionic bonds. Strong ionic bonds would not melt. This is because there is a stronger attraction between ionically bonded compounds than between covalently bonded molecules. This is due to the fact that ionically bonded atoms have a greater difference in electronegativity and the distribution of charge is more uneven.